So our model is predictive modeling for mushroom edibility, and my name is Jusan.
My name is Pidong.
And my name is Cheng Tiancui.
The datasets consist of total 61,069 hypothetical mushrooms, each categorized among 173 species. We have a diverse set of features totaling 20 variables, which include both categorical and numerical attributes. These variables are primarily divided into categories such as color, size, and habitat. Our main goal is to leverage these variables to determine whether mushroom is edible or not. Firstly, we leverage the powerful pandas library to handle missing values, ensuring the integrity of our data. We meticulously verify whether attributes contain data exceeding 50% of total attributes. If not, we make the decision to remove them. For numerical value, histograms provide a clear representation, while pie charts and bar charts prove effective for other types of data. To begin, we determine whether each column should be classified as categorical, a decision based on the count of unique values. This process ensures that each variable is appropriately identified for subsequent processing. Next, we take a strategic approach by sorting the data types based on two variables. This method allows us to distinguish between numerical and non-numerical data types, paving the way for tailored pre-processing strategies. Once sorting is complete, we apply a pipeline to our dataset, and the result is stored in a new variable called xPrepared. Having successfully applied the pre-processing pipeline to our variables, the next step is just splitting data into an 80% training set and a 20% test set.
So our initial step was to test a variety of classifiers to determine their performance. We explored decision trees, neural networks, random forests, k-nearest neighbors, and Gaussian naive Bayes, AdaBoost, and support vector machines. After conducting extensive testing and evaluation, we narrowed down our selection to the top 3 models that demonstrated exceptional accuracy and low classification error rates. These models are random forest, KNN, and SVM. It's worth noting that we chose SVM over neural networks, despite the latter achieving 100% accuracy in our initial tests. We made this decision because we wanted to explore the potential for further improvement. Our focus is on minimizing false negatives rather than aiming for a classification error rate or accuracy. We used confusion matrix and realized they all produce 0 false negative. Therefore, we picked our model based on accuracy and error rate again. Then we reduced the number of attributes by using mutual information score and select the top 7 attributes with the highest score. However, the accuracy decreased and the error rate increased for all classifiers. So we can see that we lost some informative data. Next, we tuned hyperparameters for SVM and realized there is an increase in accuracy and decrease in error rate. However, there is one false negative found in the bottom left corner from the graph. This is extremely dangerous for our task. Then we tuned a random forest. The accuracy and the confusion matrix remain the same. And lastly, for KNN, we found out that k equals to 1 has lower classification error rate than k equals to 3. So we can conclude that k equals to 1 is a better parameter for the KNN in our case.
We encountered a few issues over the course of this study. Many features in the dataset were very sparsely populated, and this made imputation difficult because of the small sample size. We couldn't in good faith use the mean or the most frequent for something that was filled for 5,000 entries compared to 60,000, for example. Our initial models were also extremely high in accuracy, which made us suspicious. We considered the possibility that all the models were overfitted, which is why we tried to reduce the number of features using the mutual information score. However, when we compared the reduced models to the initial models, we found that every single model was significantly less accurate. This would suggest that the features dropped were actually informative and contribute significantly to the model. So knowing this, we decided to proceed with the unmodified models. In conclusion, the KNN model with k is equal to 1 was the best performing model overall. However, what happened with the feature selection raised some questions. Were the features dropped due to the less than 50% fill rate also significant? Based on our results, we concluded that the mutual information score was an ineffective method of feature selection for this dataset. For future studies, we suggest the following. Perhaps implement more sophisticated feature selection methods such as extremely randomized tree classification, or explore neural networks in greater depth as we did only a cursory examination in the study.